Hey guys, welcome back to my channel where we explore the latest and greatest in the world of technology. Today, we are going to talk about something that's been making waves in the scientific community for quite some time now: quantum machines. Quantum machines, also known as quantum computers, are not your regular computers. They're a new type of computing technology that use the principles of quantum mechanics to process information. This means that they can solve certain problems that classical computers simply can't. So, let's dive in and explore some of the interesting features of quantum machines. First up, let's talk about qubits. Qubits are the basic building blocks of quantum machines. They're the equivalent of bits in classical computers. However, unlike bits, qubits can exist in multiple states at once, thanks to a principle called superposition. This means that qubits can represent both a 0 and a 1 at the same time. This may sound strange, but it's what gives quantum machines their massive computational power. Another fascinating feature of quantum machines is entanglement. Entanglement is a phenomenon where two qubits become linked in such a way that the state of one qubit affects the state of the other, no matter how far apart they are. This means that by manipulating one qubit, you can manipulate another qubit that's potentially located on the other side of the world. This is what Albert Einstein called spooky action at a distance. But what does this mean for computing? Well, entanglement is what allows quantum machines to perform multiple calculations at once. This is known as quantum parallelism. With classical computers, if you wanted to perform multiple calculations at once, you'd need multiple processors. With quantum machines, you just need entangled qubits. This means that quantum machines can solve certain problems exponentially faster than classical computers. Some text goes here. So, what are some of the problems that quantum machines can solve faster than classical computers? One example is prime factorization. Prime factorization is the process of breaking down a number into its prime factors. For example, the prime factors of 15 are 3 and 5. While this may seem like a simple problem, it's actually incredibly difficult for classical computers to solve when the numbers get really big. This is where quantum machines shine. With quantum machines, you can use a quantum algorithm called Shor's algorithm to factor large numbers in a fraction of the time it would take a classical computer. Another problem that quantum machines excel at is simulating quantum systems. Quantum mechanics is the branch of physics that deals with the behavior of particles at the quantum level. Simulating quantum systems is incredibly difficult for classical computers because quantum systems can exist in multiple states at once, just like bits. This means that you need an enormous amount of computing power to accurately simulate even small quantum systems. Quantum machines, on the other hand, can simulate quantum systems with relative ease. Finally, let's talk about quantum cryptography. Cryptography is the process of encrypting information so that only authorized parties can access it. Classical cryptography is based on mathematical algorithms that are difficult to reverse engineer. However, with enough computing power, these algorithms can be cracked. Quantum cryptography, on the other hand, is based on the principles of quantum mechanics. The act of observing a quantum system changes the system, which means that if someone tries to intercept a quantum message, the act of interception will change the message in a way that can be detected. This makes quantum cryptography incredibly secure. So, there you have it, guys. Those are just a few of the interesting features of quantum machines. As you can see, quantum machines are truly revolutionary and have the potential to change the world as we know it. They're still in their early stages of development, but scientists and researchers are working hard to improve their capabilities and solve more complex problems. There are also a few companies, such as IBM and Google, that have already built their own quantum machines and are offering cloud-based quantum computing services to businesses and researchers. One of the exciting things about quantum machines is that they're still in their early stages of development, which means that there's a lot of room for innovation and improvement. Researchers are constantly discovering new ways to improve the performance and efficiency of quantum machines. For example, some researchers are exploring the use of topological qubits, which are more resistant to external interference and could lead to more stable and reliable quantum machines. Another interesting development in the field of quantum machines is the use of quantum machine learning. Machine learning is a branch of artificial intelligence that allows machines to learn from data without being explicitly programmed. Quantum machine learning is the use of quantum machines to perform machine learning tasks. This could lead to more powerful and efficient machine learning algorithms that could revolutionize industries such as finance, healthcare, and transportation. Despite all the exciting possibilities that quantum machines bring, there are also a few challenges that need to be addressed. One of the biggest challenges is the issue of quantum decoherence. Decoherence is the process by which a quantum system loses its coherence and becomes entangled with its environment. This can cause errors in quantum calculations and limit the capabilities of quantum machines. Researchers are working on ways to mitigate the effects of decoherence, such as using error-correcting codes and better environmental control. In conclusion, quantum machines are truly fascinating and have the potential to change the world in ways that we can't even imagine yet. They're still in their early stages of development, but the progress that has been made so far is impressive. From qubits to entanglement to quantum cryptography, quantum machines have a range of interesting features that make them unique and powerful. As the field of quantum computing continues to advance, we can expect to see even more exciting developments and breakthroughs.